Welcome back to our BCIS 4345 Network and System Security class. Today, we're diving into a super important topic, Identity and Access Management, also known as IAM. This is crucial for keeping our networks secure. Before we get started, don't forget to like, share, comment, and subscribe to our channel to stay updated with all our latest content. Let's jump right in. By the end of this module, you should be able to 1. Describe different types of authentication credentials. 2. List authentication best practices. 3. Define access controls and explain how they can be used. First up, let's talk about the types of authentication credentials. Authentication credentials are what we use to prove our identity. The most common type? Passwords. But, as we'll see, they have their weaknesses. Passwords are the most common type of IAM authentication today. They're simple to use but have significant weaknesses. Why? Because they're linked to human memory. The best passwords are long and complex, but they're also hard to remember, especially when we have so many accounts. Passwords can be attacked in various ways, like brute force attacks, where every possible combination is tried until the correct one is found, or password spraying, which uses common passwords across multiple accounts. Attackers can also steal password files and use software to crack them. Scary, right? Offline brute force attacks are even more dangerous because attackers work with stolen files offline, making it harder to detect. Other methods like dictionary attacks and credential stuffing can compromise your accounts using common words or stolen credentials across multiple sites. Now, let's talk about rule attacks, a clever way hackers crack passwords. They follow 3 basic steps. First, hackers grab a small sample of stolen passwords. Then, they analyze this sample to find common patterns, like password length and character types. Finally, they create masks based on these patterns to guess passwords more efficiently. By using these masks, hackers can crack passwords faster. This is why strong, unique passwords are so important. Another type of authentication credential is something you have, tokens and security keys. These can be hardware or software based. A common example is a token that displays a dynamic value called a one-time password, OTP. Multi-factor authentication, MFA, combines more than one type of authentication credential, like something you know and something you have. Biometrics are methods for verifying identity based on unique physical or behavioral traits. Physiological biometrics, specifically, uses physical characteristics like fingerprints, facial features, and eye patterns. For example, specialized biometric scanners, such as retinal scanners, use low-energy infrared light to map the unique patterns in a person's retina for authentication. There are 2 basic types of fingerprint scanners. A static fingerprint scanner takes a picture of your fingerprint and compares it with an image on file. On the other hand, a dynamic fingerprint scanner uses a small slit or opening to capture the fingerprint. Beyond fingerprints, other unique characteristics can be used for authentication. For example, a person's veins can be identified through a vein scanning tablet. Additionally, even a person's gait, or the way they walk, can be used as a biometric identifier. Let's explore some standard input devices used for biometric authentication. First, voice recognition uses a regular computer microphone to identify users by the unique qualities of their voice. Next, an iris scanner employs a standard webcam to capture and analyze the distinctive features of the iris. Lastly, facial recognition systems use nodal points on your face, specific landmarks like the distance between your eyes or the shape of your nose, to verify your identity. While biometrics offer advanced security, they do have some drawbacks. First, specialized hardware for biometric scanning can be quite expensive. Second, these systems aren't perfect. They can have errors and may sometimes be fooled. Lastly, there's the issue of efficacy, or how effective these systems really are in practice. It's important to weigh these factors when considering biometric solutions. Cognitive biometrics is about using a person's unique perception and thought processes for authentication. It's often easier for users because it draws on their personal experiences. Also known as knowledge-based authentication, cognitive biometrics includes methods like Microsoft's picture password for Windows 10. Users choose a picture and create at least 10 points of interest, specific areas to touch or interact with to log in. Behavioral biometrics authenticate users based on their normal actions. One example is keystroke dynamics, which analyzes the rhythm of a user's typing. Keystroke dynamics looks at variables like dwell time, how long you hold down a key, flight time, the interval between key presses. The great thing about keystroke dynamics is that it doesn't need specialized hardware, making it a practical and promising method. Knowledge check. You are researching elements that can prove authenticity. Which of the following is based on unique biological characteristics? A. Something you exhibit. B. Something you have. C. Something you are. D. Something about you. The correct answer is something you are. Something you are is based on unique biological characteristics that cannot be changed. To secure password digests, one effective method is salting. This involves adding a random string, known as a salt, to the user's cleartext password before hashing. Salts significantly slow down dictionary and brute force attacks and help thwart rainbow table attacks. Another method is peppering. Here, the password digest is created and then encrypted with a symmetric encryption key before storage, adding an extra layer of security. For enhanced password security, key stretching is a valuable technique. It involves using hash algorithms designed to be intentionally slow, making it harder for attackers to crack passwords. Three prominent key stretching algorithms are bcrypt, PBKDF2, and Argon2. These algorithms increase the time required to compute the hash, adding an extra layer of protection against brute force attacks. To effectively manage passwords, consider the following solutions. Password vaulting, which stores credentials in a secure database, protected within your organization's network. User password managers, which is software or online tools that keep your passwords and login info safe and easily accessible. And hardware password keys, which are physical devices that act as hardware-based password managers, enhancing security. These tools help keep your passwords secure and organized, reducing the risk of breaches. Now, let's talk about how to keep passwords secure. First off, always change default passwords. They're easy targets for attackers. Next, don't reuse passwords. Using the same password everywhere is risky. If one account gets compromised, all your accounts might be at risk. Now, a quick tip. Forget about password expiration policies. Instead of making passwords change frequently, focus on making them strong. Also, set a minimum password age, so users have to use a password for at least 1 day before changing it. When setting up user accounts, make sure you follow provisioning policies for creating strong passwords. And, when someone leaves the organization, deprovisioning policies should kick in to suspend or delete their accounts right away. Stick to these practices, and you'll be a step ahead in securing your accounts. Now, let's talk about Single Sign-On, or SSO. Single Sign-On is a convenient way to manage your logins. Instead of juggling multiple usernames and passwords for different accounts, SSO lets you use one set of credentials to access everything you need. Identity management with SSO means you use a single authentication credential across various networks. This can be especially useful if those networks belong to different organizations, which brings us to federation, a way to share your identity across different networks that aren't all under the same roof. Two popular technologies that make SSO work are Security Assertion Markup Language, SAML, and Lightweight Directory Access Protocol, LDAP. SAML is often used for web-based SSO, while LDAP helps manage and access directory information like user credentials. In short, SSO simplifies your digital life by letting you use one login to rule them all, and technologies like SAML and LDAP help make this possible. Here's a quick rundown on 2 key technologies that power single sign-on. Security Assertion Markup Language, SAML, is an XML-based standard that helps web domains securely exchange authentication and authorization data. Basically, SAML lets your login credentials be managed by a single identity provider rather than scattered across every service you use. So, when you log in once, you're set for all the services that use SAML. On the other hand, Lightweight Directory Access Protocol, LDAP, is like a universal directory service. It allows almost any application to pull directory information, making it a handy tool for developers. With LDAP, a single login can give you access to all databases, apps, and devices on a server, making SSO seamless and efficient. In short, SAML keeps your login info in one place, while LDAP helps various apps and systems access that info for smooth, single sign-on experiences. Let's break down some key authorization and authentication tools you might come across. OAuth is like a bouncer for your apps. It's an open-source framework that helps manage access to resources securely. Think of OAuth 2.0 as the guide that lets apps access your data without needing to see your password. OpenID works hand-in-hand with OAuth. It's a protocol for confirming who you are. Imagine it as a badge that proves your identity, which can be used with OAuth to log you in across various sites. Shibboleth is a bit like a VIP pass for single sign-on, SSO. It's open-source software that lets you log in once and access multiple services. It uses federation standards to make sure your login info can be shared safely between different organizations. In a nutshell, OAuth manages permissions, OpenID verifies your identity, and Shibboleth streamlines your login experience. Passkeys represent a modern approach to authentication that skips the need for passwords. Passkeys are stored in hardware and manage multiple authentication factors within a single device. Instead of relying on passwords, they use a more secure, integrated method. When you use a passkey, your device's operating system handles the authentication process, making it both convenient and secure. What's cool is that passkeys are discoverable. This means if you're signing in from one device, an enrolled device can automatically and securely send the passkey through an encrypted channel to the device you're using. It's a slick way to streamline security without the hassle of remembering passwords. Knowledge check. Which of these is not a key stretching algorithm? A. Argon 2. B. Bcrypt. C. PBKDF2. D. MD5. Answer: MD5. Using general-purpose hash algorithms like MD5 and SHA is not considered secure for creating digests because these hashing algorithms are designed to create a digest as quickly as possible. The fast speed of general-purpose hash algorithms works in an attacker's favor. To help control access to critical systems, let's take a look at different access control schemes. They're like security blueprints built into your software and hardware, helping administrators manage who can access what. First up is Discretionary Access Control, DAC. This scheme is the least restrictive. Here, each object, like a file or a folder, has an owner who has complete control over it. So, if you own a document, you decide who gets to see or edit it. But, DAC does have its weaknesses. It relies on user decisions to set their own security settings, which can lead to inconsistent or insecure configurations. Permission inheritance. If a user runs a program, that program inherits the same permissions as the user, which could pose security risks if the program is compromised. DAC is flexible, but it's essential to be mindful of these potential pitfalls to keep your system secure. Mandatory Access Control, MAC, assigns users access controls strictly according to the custodian's desires. The following are 2 key elements to MAC. Every entity is assigned a classification label and a hierarchy based on the labels is used for objects and subjects to create levels. Microsoft Windows uses Mandatory Integrity Control, MIC, that ensures data integrity by controlling access using a security identifier, SID. With role-based access control, RBAC, this approach ties access permissions to a user's job function within an organization. Instead of managing permissions for each individual user, RBAC simplifies things by assigning permissions to specific roles. Users are then assigned to these roles based on their job duties. For example, if you're in the HR department, you might be given access to employee records, while the IT team might have access to system configurations. Next is rule-based access control. This is handy when you need to manage access based on certain rules or conditions that can change with business needs. It's like setting up rules for who can access what under different circumstances, making it adaptable to shifting business environments. Lastly, there's attribute-based access control, ABAC. ABAC takes flexibility to the next level by using policies based on various attributes, such as user role, department, or even time of day. This means you can create highly specific access rules that combine multiple attributes for precise control. These methods help streamline access management and improve security by ensuring that users only have access to what they need. An access control list, ACL, is basically a list of permissions attached to an object, like a file or folder. This list details who is allowed to access the object and what operations they can perform, such as reading, writing, or executing. ACLs are great for providing file system permissions to protect files managed by the operating system. They specify which users or system processes can access specific objects and what operations they can perform. However, ACLs come with some drawbacks. They can be inefficient and difficult to manage, especially in large enterprise settings. Managing these lists across numerous files and users can quickly become complex and cumbersome. In summary, while ACLs are useful for controlling access at a granular level, their complexity can be a challenge in larger environments. Knowledge check. Which access control scheme uses flexible policies that can combine attributes? A. ABAC. B. RBAC. C. MAC. D. DAC. Answer: ABAC. While the rule-based access control scheme uses predefined rules, attribute-based access control uses more flexible policies that can combine attributes. These policies can take advantage of many different types of attributes, such as object, subject, and environment attributes. Alright, let's wrap up by reflecting on our key objectives from this module. On a scale of 1 to 5, with 5 meaning you're super confident and 1 meaning not so much, rate your understanding of the following. Different types of authentication credentials. Are you clear on the various methods like passwords, biometrics, and tokens? Authentication best practices. Do you know the essentials, like using strong passwords and enabling two-factor authentication? Access controls. Can you define and explain how to use DAC, RBAC, rule-based, and ABAC? If you score below A4 on any of these, take some time to review the module and related exercises to boost your confidence. Keep pushing forward, you're doing great. That's a wrap for this module. Today, we covered the different types of authentication credentials, explored authentication best practices, and delved into various access control methods like DAC, RBAC, rule-based, and ABAC. I hope you found this information valuable and feel more confident in your understanding of information systems security. If you enjoyed this video, make sure to hit the like button, subscribe to the channel for more content, and leave a comment if you have any questions or thoughts. Don't forget to share this video with your friends and classmates on social media. Thanks for watching, and I'll see you in the next module.